Red EMT Conduit is manufactured and meets the requirements of NFPA 70, Article 700.10. This conduit is typically used for fire, alarm, or emergency lighting installations where visibility is crucial. The red coating is not just painted on, but is a more durable and permanent treatment. It provides additional corrosion resistance and helps prevent fading. The bright red color makes the conduit highly visible, even in low light conditions, ensuring easy identification in an emergency. EMT conduit is inherently fire resistant, providing protection for wires and cables in case of a fire. Red EMT conduit is commonly used in fire alarm systems, emergency lighting installations, smoke and carbon monoxide detectors, sprinkler systems, and security systems. Fire alarm and emergency lighting installations often require the use of red EMT conduit to ensure compliance with codes and standards. In some cases, local fire codes may specify the use of red conduit for these systems. Although red EMT conduit is the preferred choice for many fire alarm and emergency installations, painted covers for electrical boxes can also be used to meet visibility requirements. However, covers can become loose or fall off, reducing their effectiveness. Some inspectors may require the use of red EMT conduit for all fire alarm and emergency lighting installations, regardless of local codes. It's important to check with the local authority having jurisdiction, known as the AHJ, for specific requirements and approvals before using red EMT conduit. Red EMT conduit is more visually appealing than painted covers, providing a more professional and aesthetically pleasing solution. When considering the use of red EMT conduit, firstly, verify the local regulations and codes. Confirm whether the local authority having jurisdiction mandates or recommends the use of red EMT conduit for specific applications such as fire alarm systems or emergency lighting. Secondly, assess the environmental conditions where the conduit will be installed. Red EMT conduit offers enhanced corrosion resistance, making it suitable for environments where exposure to moisture or chemicals is a concern. Thirdly, evaluate the visibility requirements for the installation. The bright red color of the conduit provides high visibility, especially in low light conditions, which can aid in identifying critical systems during emergencies. Fourthly, determine the aesthetic requirements of the project. Red EMT conduit offers a more professional and visually appealing solution compared to painted covers or other alternatives. Fifthly, factor in the long-term maintenance and durability of the conduit. The durable coating on red EMT conduit helps prevent fading and provides long-lasting protection, reducing the need for frequent replacements or repairs. Sixthly, compare the cost of red EMT conduit with alternative solutions such as painted covers or standard EMT conduit. While red EMT conduit may have a higher initial cost, the benefits of enhanced durability, visibility, and aesthetics may justify the investment. Seventhly, ensure that the red EMT conduit meets the applicable industry standards and certifications. Look for products that comply with NFPA 70 and other relevant standards to ensure the safety and reliability of the installation. Eighthly, consider the ease of installation and compatibility with existing electrical systems. Red EMT conduit can be installed using standard EMT fittings and tools, making it a convenient option for both new construction and retrofit projects. Ninthly, evaluate the availability of red EMT conduit in the required sizes and lengths. Check with local suppliers or manufacturers to ensure that the necessary materials are readily available for the project. Tenthly, consult with electrical engineers, contractors, or other professionals with expertise in fire protection and electrical systems. Their input can help you make informed decisions about the use of red EMT conduit and ensure compliance with all applicable requirements. EMT, or electrical metallic tubing, is a type of unthreaded thin-wall steel raceway often used for protecting electrical wiring. It is a popular choice in commercial and industrial buildings due to its lightweight nature, ease of installation, and cost-effectiveness. When selecting EMT, it's important to consider several factors to ensure it meets the specific requirements of the application. Firstly, consider the size of the conduit. EMT is available in various sizes ranging from 1/2 inch to 4 inches in diameter. The appropriate size depends on the number and size of wires that will be installed inside the conduit. The National Electrical Code (NEC) provides guidelines for determining the correct conduit fill capacity. Secondly, evaluate the material and finish. EMT is typically made of galvanized steel, which provides corrosion resistance. However, for harsher environments, such as those exposed to saltwater or chemicals, consider using EMT with a special coating or made from a different material, such as aluminum or stainless steel. Thirdly, assess the location and environment. EMT can be installed indoors or outdoors, but it must be properly supported and protected from physical damage. In wet locations, use watertight fittings and supports to prevent moisture from entering the conduit. Fourthly, check for compliance with industry standards. Ensure that the EMT and associated fittings are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, AL. This indicates that the products have been tested and meet the applicable safety standards. Fifthly, consider the ease of installation. EMT is relatively easy to cut, bend, and join using standard tools and fittings. However, some fittings may require special tools or techniques. Choose fittings that are compatible with the conduit and easy to install. Sixthly, factor in the cost. EMT is generally less expensive than other types of conduit, such as rigid metal conduit, RMC, but the cost can vary depending on the size, material, and finish. Compare the costs of different options to find the most cost-effective solution that meets the project requirements. Seventhly, consider the availability of fittings and accessories. Ensure that a wide range of fittings and accessories, such as couplings, connectors, elbows, and supports, are readily available from local suppliers. This will simplify the installation process and reduce the risk of delays. Eighthly, evaluate the load-bearing capacity of the EMT. EMT is not designed to support heavy loads, so it's important to use appropriate supports and hangers to distribute the weight of the conduit and wiring. Ninthly, consider the grounding requirements. EMT can be used as an equipment grounding conductor, but it must be properly connected to the electrical system. Use listed grounding fittings and follow the NEC guidelines for grounding and bonding. Tenthly, consult with a qualified electrician or electrical engineer. They can provide valuable guidance on selecting the appropriate EMT and fittings for the specific application and ensure that the installation complies with all applicable codes and standards. When using EMT, proper installation techniques are crucial to ensure the safety and reliability of the electrical system. Firstly, cut the EMT to the desired length using a hacksaw, pipe cutter, or specialized EMT cutting tool. Ensure that the cut is clean and square to prevent damage to the conduit or fittings. Secondly, ream the cut ends of the EMT to remove any burrs or sharp edges. This will protect the wires from damage during installation. Thirdly, bend the EMT to the required angle using a conduit bender. Follow the manufacturer's instructions for the bender and ensure that the bends are smooth and uniform. Fourthly, join the EMT sections using couplings and connectors. Tighten the fittings securely to ensure a watertight connection. Fifthly, support the EMT at regular intervals using conduit hangers or straps. The NEC specifies the maximum spacing between supports, which depends on the size of the conduit. Sixthly, pull the wires through the EMT using a wire pulling lubricant. Avoid overcrowding the conduit and follow the NEC guidelines for conduit fill capacity. Seventhly, ground the EMT system by connecting it to the equipment grounding conductor. Use listed grounding fittings and follow the NEC guidelines for grounding and bonding. Eighthly, inspect the completed installation to ensure that all fittings are tight, supports are secure, and the system is properly grounded. Ninthly, test the electrical system to verify that it is functioning correctly and safely. Use appropriate testing equipment and follow established safety procedures. Tenthly, document the installation, including the type and size of EMT used, the location of supports and fittings, and the grounding connections. This information will be helpful for future maintenance and troubleshooting. Red EMT Conduit provides distinct advantages for fire, alarm, and emergency lighting systems. Firstly, it offers enhanced visibility. The bright red color makes it easy to identify the conduit even in low light conditions or during emergencies. This can help firefighters and other first responders quickly locate and isolate critical electrical circuits. Secondly, it provides added protection. The durable coating on red EMT conduit helps prevent corrosion and fading, ensuring that the conduit remains visible and functional for many years. Thirdly, it complies with codes and standards. Many local and national codes require the use of red EMT conduit for fire alarm and emergency lighting systems. Using red EMT conduit helps ensure compliance with these requirements and avoids potential fines or delays. Fourthly, it improves aesthetics. Red EMT conduit can provide a more professional and visually appealing solution compared to painted covers or other alternatives. This can be especially important in commercial buildings or other public spaces where aesthetics are a concern. Fifthly, it simplifies maintenance. The distinct color of red EMT conduit makes it easy to identify and maintain the fire alarm and emergency lighting systems. This can help reduce the risk of errors or oversights during maintenance activities. Sixthly, it enhances safety. By clearly identifying the fire alarm and emergency lighting circuits, red EMT conduit helps prevent accidental damage or disruption to these critical systems. This can improve the safety of building occupants and first responders. Seventhly, it reduces the risk of confusion. In buildings with multiple electrical systems, red EMT conduit helps distinguish the fire alarm and emergency lighting circuits from other circuits. This can reduce the risk of confusion or errors during maintenance or repairs. Eighthly, it provides a clear visual signal. The bright red color of the conduit serves as a clear visual signal that the system is related to fire safety or emergency response. This can help alert building occupants to potential hazards and encourage them to take appropriate action. Ninthly, it promotes consistency. Using red EMT conduit throughout the fire alarm and emergency lighting systems promotes consistency and uniformity. This can make it easier to train personnel and maintain the systems over time. Tenthly, it demonstrates a commitment to safety. By using red EMT conduit, building owners and managers demonstrate a commitment to safety and fire protection. This can enhance their reputation and build trust with building occupants and the community. When installing red EMT conduit for fire alarm or emergency lighting systems, there are several important considerations to keep in mind. Firstly, verify the local code requirements. Check with the local authority having jurisdiction to determine whether the use of red EMT conduit is required or recommended for the specific application. Secondly, select the appropriate size and type of conduit. Choose the correct size of EMT conduit to accommodate the number and size of wires that will be installed. Also, select EMT conduit with a durable coating that is suitable for the environmental conditions. Thirdly, use listed fittings and accessories. Ensure that all fittings, connectors, and supports used with the red EMT conduit are listed by a recognized testing laboratory, such as Underwriters Laboratories AL. Fourthly, properly support the conduit. Support the EMT conduit at regular intervals using conduit hangers or struts. The maximum spacing between supports is specified in the National Electrical Code, NEC. Fifthly, ground the system correctly. Properly ground the red EMT conduit system by connecting it to the equipment grounding conductor. Use listed grounding fittings and follow the NEC guidelines for grounding and bonding. Sixthly, protect the conduit from physical damage. Protect the red EMT conduit from physical damage by installing it in a location where it is not likely to be struck or damaged. If necessary, use additional protection such as conduit guards or barriers. Seventhly, avoid sharp bends or kinks. Avoid making sharp bends or kinks in the red EMT conduit, as this can damage the conduit and make it difficult to pull wires through. Use a conduit bender to create smooth, uniform bends. Eighthly, seal the conduit to prevent moisture entry. Seal the red EMT conduit system to prevent moisture from entering the conduit. Use watertight fittings and sealants in wet locations. Ninthly, label the system clearly. Label the red EMT conduit system clearly to identify it as a fire alarm or emergency lighting circuit. Use permanent labels that are resistant to fading or weathering. 10thly, inspect the installation thoroughly. Inspect the completed installation thoroughly to ensure that all fittings are tight, supports are secure, and the system is properly grounded and labeled. The NEC provides detailed requirements for the installation of EMT, including specific guidelines for supporting, grounding, and protecting the conduit. Article 358 covers the use and installation requirements for electrical metallic tubing, ENT. Some key aspects of NEC Article 358 include approved uses, size, number of conductors, supports, and grounding. Article 358.10 covers uses permitted. EMT can be used for both exposed and concealed work. It can be installed in dry, damp, and wet locations, provided that appropriate fittings and supports are used. Article 358.12 covers uses not permitted. EMT cannot be used where subject to severe physical damage. It cannot be installed in direct contact with the earth or in areas subject to corrosive fumes or vapors unless made of a material suitable for the condition. Article 358.20 covers size. The minimum size of EMT allowed is 1/2 inch electrical trade size. The maximum size of EMT allowed is 4 inches electrical trade size. Article 358.22 covers number of conductors. The number of conductors permitted in EMT is governed by the conduit fill requirements specified in Chapter 9 of the NEC. These requirements limit the percentage of the conduit's cross-sectional area that can be occupied by conductors. Article 358.30 covers supports. EMT must be securely fastened in place at intervals not exceeding 10 feet. Additional supports may be required near boxes, cabinets, and fittings. Article 358.60 covers grounding. EMT can be used as an equipment grounding conductor if it meets the requirements of NEC Article 250. Use listed grounding fittings and ensure that all connections are tight and secure. In addition to the general requirements of Article 358, there may be specific requirements for the installation of EMT in fire alarm and emergency lighting systems. For example, some local codes may require the use of red EMT conduit for these systems, as discussed earlier. Other requirements may address the separation of fire alarm and emergency lighting circuits from other electrical circuits, the use of fire-rated fittings and supports, and the installation of emergency power systems. It is essential to consult with the local authority having jurisdiction, UJ, and to review the applicable codes and standards before installing EMT in any electrical system. Proper installation and compliance with all applicable requirements are crucial to ensure the safety and reliability of the system. When working with electrical systems, safety is paramount. Always follow established safety procedures and use appropriate personal protective equipment (PPE). Firstly, to energize the circuit before working on it. Always turn off the power at the circuit breaker or disconnect switch before working on any electrical circuit. Verify that the circuit is de-energized using a voltage tester. Secondly, use appropriate personal protective equipment (PPE). Wear safety glasses, gloves, and other appropriate PPE to protect yourself from electrical shock, burns, and other hazards. Thirdly, use insulated tools. Use tools with insulated handles to prevent electrical shock. Make sure that the insulation is in good condition and free from cracks or damage. Fourthly, follow lockout/tagout procedures. Follow lockout/tagout procedures to prevent the circuit from being accidentally energized while you are working on it. Place a lock and tag on the circuit breaker or disconnect switch to indicate that the circuit is being worked on. Fifthly, be aware of your surroundings. Be aware of your surroundings and avoid contact with grounded surfaces or other conductive materials. Keep the work area clean and free from clutter. Sixthly, never work alone. Always work with a partner or co-worker who can assist you in case of an emergency. Seventhly, follow the National Electrical Code, NEC. Follow the requirements of the NEC and other applicable codes and standards. These codes provide guidelines for safe electrical installations. Eighthly, attend safety training. Attend regular safety training to stay up to date on safe work practices and procedures. Ninthly, inspect your equipment regularly. Inspect your tools and equipment regularly to ensure that they are in good condition and functioning properly. Tenthly, know your limitations. Know your limitations and do not attempt to perform tasks that you are not qualified to do. Seek assistance from a qualified electrician or electrical engineer when needed. By following these safety precautions, you can minimize the risk of electrical accidents and injuries. Remember that electricity is a powerful force and it should be treated with respect. Always prioritize safety when working with electrical systems.